Hello everyone, and welcome to the MongoDB introductory session. My name is Mohit, and I am a part of the support team at Edureka. Now, before we start, I would like to thank all of you for joining in the session, and I'm glad to inform you that we have received an overwhelming response for this session. Thank you all for choosing Edureka as your learning partner. Now, we just wanted to inform you that since we have a large audience today, your instructor may not be able to take all the questions during the class due to some time limitations. We hope that you will understand this. Uh, in the meanwhile, our technical experts are available live on Twitter to answer your queries. You may post your questions on Twitter. You can mark them to at EdurekaIN using a hashtag AskEdureka. We'll display that in the next slide itself. You'll get these details. Our team will be glad to answer your queries immediately. Thank you for your patience. And now I would like you to introduce your instructor with your instructor, Mr. Rana. Now, Mr. Rana comes with a vast background of over 10 plus years of experience in big data, and he has been working in MongoDB precisely. Mr. Rana is working at an architect level in one of the biggest MNCs across the globe. And from here, I would like to hand it over to Mr. Rana without wasting any more time. Mr. Rana, can you hear us?
Yeah, hello.
Yes, thank you
Am
very
I
much.
audible?
Yes, it is over to you, Mr. Rana.
Okay. Thank you, Mohit, for the introduction. And thank you all for joining this session, the introductory session of MongoDB. So we'll not, waste much time as he has already introduced me. So let's start, today's session. So today in the introductory session, what we'll be doing is we'll be covering these objectives. Why do we need NoSQL databases? The benefits of NoSQL databases over RDBMS, the traditional database management system. We'll also do some comparison, between these two notions, NoSQLs versus SQL DBs, and also we will try to see that what all current, challenges that we face today can be solved, especially using MongoDB, because this is MongoDB introductory session. We'll try to see some of the use cases where it can be implemented, which industry it can be used, and when whatnot. We'll try to see the use cases, and also we'll see that currently in industry what all big names they're using MongoDB. They have already migrated. I mean, there are a lot of clients that they are using, but some of the big names we'll try to highlight today in this session, just to give you some some light that how it is getting as far as the popularity is concerned. Also, we will see that some job trends on MongoDB. Okay, so with that said, I just got an quick comment from Somadeep that no audio. Is that a problem for everybody? Can somebody confirm that I am not audible? Okay, audio is fine, able to hear. I have audio, can hear you. You're fine. I think most of them you can hear me. So maybe a temporary issue with his internet connection. That's fine. Let's go ahead. Very good. Okay, great. Okay, so these are the objective that's I will try to cover. Right. Okay, so before we start to the actual why NoSQL section, that why should we learn NoSQL at all, the other two notions that we have today, or we already have it, and we have been having it before NoSQL comes into picture, right? Came into picture, right? The most popular one is our traditional RDBMS system, namely Oracle, MySQL, Microsoft SQL Server, DB2, okay, the relational database management system. And also we name it as OLTP, right? Online transaction processing, because these persistent management, these database management systems, we generally use we have been using this in most of our applications, in most of our development, and we have been using this for our online transaction processing, real-time persistence, and real-time querying for the from the database management system and show it to the user in some of those cases. So these are the most popular one that we have been using. The second one we have been using is for that analytical processing, online analytical processing, or data warehouse system, or the data shared service. Some of the examples are like Netezza, SAP HANA, or Oracle Express, right? So these systems are mainly helps us to do analytical processing mainly in the background, right? So we have, let's say, large data set, and we need to run a lot of aggregation query, right? We need to learn a lot of analytical process and get to know some of the trends of the current users, or current behavior of the industry, or current usage of my users, and those stuffs like that. Based on that, you can take some business decisions or something for analysis, right? So those are the systems which we have today for this online analytical processing kind of stuffs. And also we have it like data warehouse systems. Now the third thing that it's getting introduced in the decade of 2000, right? 2004, 2005, that time frame, when first time Google introduced this big table concept, right? We started having some different notions of big data and NoSQL technologies. Examples, obviously, most of you already know, but just to reiterate, our video on MongoDB that we'll cover today. The other examples like HBase, Cassandra, CouchDB, Neo4j. Okay, so these are the examples that that we have today as far as the NoSQL world is concerned. Now, friend, just before going ahead, when we say NoSQL, right? What does that mean, and why is it called NoSQL at all? Let's get a step back. Let's say whenever we started our journey with the with this application development, database management, right? We have been having this SQL. So we have been seeing this structured query language, right? So we know that generally we save the data in a structured format, in a relational format, so that we can query, we can do a structured, we can fire some structured query and all, right? So we have been having this SQL concept, so we call it structured query language. Now in the last decade, there are few use cases or few scenarios or few trends that we have been seeing where we see some of the pattern of data are getting changed. I'll come to that in the later slides. And we found that there are some other than the structured data, right, that row column kind of structure, right? So we have started receiving some different structures in the sense some of the data they do not have any structure at all. Some unstructured data like images, binary files, PDFs, okay, videos. Okay, so these unstructured data, and also some semi-structured data in the sense some data are there which have some structure, but I am not able to put it into a row column format, so I am not able to draw it in a relational diagram or something of that kind. And we started facing some issues that SQL is not the only way to solve those problems. Okay, so we have started facing to you know, we have started facing some issues which will be solved by some other mechanism, right? And that time the technology which actually supported us, this NoSQL technology, we call it not only SQL. That means not only SQL is satisfying my need, I need something else as well. How I need that, why I need that, I'll just come one by one. Okay. Okay, just before that, I think there are some questions. Let me see if I have any questions. Shiva Prasad is saying, is Hadoop and MongoDB does same for a customer in terms of results? Okay, so Shiva Prasad, the question that you asked is Hadoop and MongoDB does same for the customer. The straight away answer is no, but I'd like to throw some light on it as well. I'll come to it. Okay, I'll come to it. Vishal is saying, what is OLTP and OLAP? So Vishal, OLTP is online transaction processing, where you develop some system which will save data, real time or near real time, right? And you get the response near real time. And OLAP is online analytical processing, where you do mainly analytical queries or fire analytical queries in the background, and and get the resultant data to feed your OLTP database. Jonathan is saying, Jonathan, okay, hi Jonathan, thank you. Jonathan is a MS SQL DBA. Okay, thanks Jonathan, good to know that. Okay, so okay, now let's continue. In the why NoSQL part, right? The one that we have started seeing, I think there are some other questions as well. Jonathan is saying, what is the difference between Microsoft SQL DBA and MongoDB? So Jonathan, it's basically two different technologies, right? So MS SQL DBA will know about the bits and pieces and administration stuffs of Microsoft SQL, and MongoDB obviously will be for Mongo only. Okay, so that's the main thing. Jaya Kumar is saying, does the NoSQL will be able to support it structured data? If so, with its right, Jonathan, right, Jaya, it should be able to support both. So just hold on to these questions. Let me go ahead with some of the slides. I think most of your questions will be answered automatically. Okay, so for some time, just hold on to your questions. Okay, so that we can complete it, we can go ahead. Okay, because we don't have much time, we have only 1 hour, right? So let us go ahead. Okay, so as we have been discussing, friends, so mainly what we have started seeing is, we have started seeing different kinds of data, different kind of growth of data. Okay, now there are few aspects of it. Data with higher and larger volume. We have started seeing voluminous data of most of the applications. Most of the applications, they started dealing with a lot of data, like Facebook, the New York Stock Exchange, and then whatnot. A jet airways, right? When it actually travels from one air station to another air station, right? It loads a lot of GB. It's almost loads like 500 GB data, right, in one travel. So many parameters, like weather parameters, different altitude, latitude, lot of things, temperature, different stuffs. It basically saves, and and one more example of voluminous data is our government India Aadhaar project, right? So it's almost 15 to 20 petabyte data. So till now we have been, I mean, before this 2004 2005, we have been dealing with data with, let's say, in GB level, right? And then it crosses that, it basically reaches terabyte, and then petabyte level also. Okay, so all we are trying to say is, the volume, the way it's basically getting increased, we have started facing some problem. What is the problem we have started facing? The main problem is, when data grows in those level, my RDBMS or my traditional database systems, it's it's having some problem to process those data. I still can put lot of hard disks. I still can put lot of spaces in my system, okay, or in my SanDisk, right? And I can still save those data somehow. But what is the point if you are not able to process, or if you are not able to use those data properly or in an efficient way, or or user is not getting the proper responses within a efficient timely manner, right? What is the point just to save it, correct? So that's the first thing that we have started seeing. The volume is one factor. The second is data in motion, the velocity. Okay, when we say velocity, right, the pace the data is growing. I'll share you some statistics. The pace the data is growing nowadays, and also in near future also, we'll see the pace it's growing. It's very it was very hard to manage the pace with the traditional systems. Okay, and why that is also something that we'll see. Say for example, the fastest growing app, the video streaming, right, the streaming data, okay, and also the requirement from the user. Every user wants a very fast response system, right? So if you just put a query or click on a page, and if it takes a lot of time, like takes a minute or so, no one will actually come to your application, correct? So everyone needs it very fast. So second thing is that velocity. So the moment volume increases, right, obviously whenever you actually fire a query in your RDBMS table, right, if it will obviously take a lot of time if it crosses some million records. So querying from 1,000 records table and querying from 1,000,000 records table obviously will vary. I know there are different mechanism to reduce that response time, like indexing and partitioning and all, so those things are there. But we have started seeing some limitations after some boundary, like when it actually crosses the level of gigabyte to petabyte level, right? And then comes the variety one that I was just talking about. We have been seeing the relationships, yeah, user, student, user, account, okay, account, then different accounts, user, address, class, student, different relationship. We have been seeing it, correct? But we have been seeing a lot of applications which are gaining popularity, who does not have only similar row column relationship. It has got images, it has got videos like YouTube, Facebook, Twitter, okay, a lot of social media apps, okay, and also maps. So lot of data we are seeing. It does not only have a structured form, it also has different form, like unstructured text, media. Say for example, log files. We did not even think of it in the year of 90s, right? Say for example, we have been saving the log files at the background, application is running and logs are getting generated, right? What we saw is that logs files are storing so much of data, and if we just look into it, if we analyze it in a proper way, we can understand the user intention, we can understand the trend, right? And from there we can draw some excellent business decision, which will be very much beneficial for us to keep a pace in the industry. So when logs are getting huge and huge and huge, we simply ignored that earlier, right? But we have started seeing that no, if we need to process those log files, which are actually in petabyte and in very big volumes and all, those are not structured. Then how do I process those? So this variety, multimedia, as I said, right, it's totally unstructured, the binary format. Okay, so we have started seeing variety. I know those, I mean we can save these things in a blob format, but the problem is whenever you actually put something in a blob format in your traditional RDBMS, right, you are facing some performance issues. That's obvious. Okay, it's very heavy, correct? And then veracity. Veracity, it's a very important term, friends. It's just, keep this in mind. Sometimes what happens is the uncertainty due to data inconsistency and incompleteness, ambiguities, latency, deception, model approximation. Sometimes what happens is you simply you have to start your development project, right? But you don't know what requirements will come tomorrow, what new things will come tomorrow, how your data model is going to change, okay? And based on that change, how you are going to adapt your application layer, correct? You don't know that sometimes, because due to the agility that we have today in the industry, or every time user wants something new every day, okay? And it's very difficult for the developer, for the architect, and for the person who actually designing the data model to to foresee everything upfront. It's very difficult. So we do not know, we are still uncertain, and also we are uncertain going forward as well, that what is coming tomorrow. In these cases also, you need to have support for a kind of technology, or kind of database that will support you to adapt you very fast, okay, in this agile world, okay? Because you have to keep pace with the development, you have to be there in the competition, okay, as compared to your rivals or your competitors, right? Otherwise, somebody will come and just gain the business. So these are some of the aspects that we started facing, that okay, where my RDBMS or my traditional things are having some issues, okay? When I combine that, I face no, something else I need, okay? Now let me give you some background of why it is having problem when my data is growing bigger and bigger, right? So before that, let me give you one quick example. Let's say you can store data in your disks. You can buy a number of disks you want, right? You can save it in a number of ways. But the problem is, even if your disk cost is not that much today, it's actually in your memory cost is not that much today. That is also getting faster. Network speed also we are seeing a lot of improvements. But the problem that we still have is the IO speed of your system. Whenever you save something in your disk, right, ultimately you have to have a very good IO speed to read that. But as compared to the cost of different things, as compared to the improvements of your memory, processor, your disk, SSD or non-SSD, whatever, your IO speed is not gaining that much, right? So basically what happens is, even if you store, let's say, 1 terabyte of data in one system, okay, and you have, let's say, 100 MB per seconds of IO speed, and you have 4 IO channels, right? You will have to read the data with that speed only, not more than that. Now let's say the more the data grows from 1 TB to 2 TB to 3 TB, your slowness or your read speed will decrease day by day. So what we can do to improve this? What we can do to improve my read performance? Because as I said, saving the data, storing the data was not a problem. We can still buy a number of disks, we can save the data. That's not a problem. Problem comes when we have to process it. So to process it in an efficient way, process it in a faster way, process it in a better way, so that I can support my user expectation, or I can give the user a proper input. So we have started thinking that how can I improve my read performance mainly. I'm not saying that write performance is not needed, but what I'm trying to say is I first started facing the issues when I saw that my read performance is getting decrease and decrease. So what are the things that I can do to improve my read performance? One thing is that I can buy higher configuration systems, like much faster memory, a lot of memory, lot of processors, okay, in the same system itself, okay. So that is called vertical scaling or scale up. In the same system, you can have more resources, Okay, you can have better memory configuration, you can have better processor configuration, so that you gain with your read speed. But the problem here is, friends, problem is, at one point of time you have to stop. I mean, after one point of time, there are no scope for improvement even if you put more resources. So that's where the problem is. Even if you buy a lot of higher configuration systems, also scale up has some limitation after some point of time. And also it is costly, because buying higher configuration system also is very much costly. The other option is, why don't I distribute that 1 TB of data into different chunks, into different systems, like 100 GB, 100 GB into 10 machines, right? In a way, I can directly gain near equal to 10 times of read speed. And for that, I don't have to go for a higher configuration system. A similar commodity hardware can be used into different parts, right? I mean, I can use multiple systems of similar kind of commodity hardware and distribute my data, okay, and manage it from one common location. In a way, what I'm doing is that 1 TB of data, just trying to visualize that 1 TB of data, I am actually distributing it into 10 chunks, for example, in 10 machines, okay? And what I'm doing is, instead of reading it from one, I'm actually parallelly reading it from this 10 different systems. So in a way, I can I actually have to read 100 GB from one system. So directly I'm gaining 10 times of my read speed, isn't it? So this particular process is called scaling out of your data or of your system. Another name is horizontal scale out, and we have started seeing horizontal scaling or scale out is much more efficient than scale up, because number one, you don't have a limitation. Whenever you see some data growth, or whenever you started seeing the moment when you started your development, you did not have that much of configuration or that much of space. You simply can have another system in cluster. You can actually grow with your applications based on your application demand, or based on your user demand. So it's much more easier and much more cheaper as well. The reason I'm saying cheaper, because for that you don't have to buy higher configuration systems. You can use lower cost commodity hardware itself. So that's another reason that we scale out is much more easier. Now, so you might think that, okay, when I'm saying scaling out, can that be done in can't that be done in our traditional RDBMS system? Yes, that can be done. But the problem is, most of the system, it will in most of the cases it will be very much complicated to manage. So I need to have some way which will give me faster read performance, which will give me easiest way of maintaining this distributed architecture, right? The moment you are actually distributing your data into multiple systems, you are also inviting some challenges to maintain that cluster itself, to maintain that architecture itself. So I need to have some technical stack which will actually give me a lot of benefits of maintaining it easily, correct? And also this monitoring and managing the distributed architectures, as I said. And also we discussed this agility with fastest changing world. I mean, when I say fastest changing world, I need to have something when my industry is changing very fast, I have to cope up with the changes. Okay, I have to have something where my development time is very less, my time to market is very very fast. That I have to keep in mind. So these are some of the very important point. And okay, now this slide, if you look into this slide, friends, the data growth pattern I was talking about, this data growth pattern, right? If you see, in the year 2006, the unstructured data and the ratio of unstructured data and structured data was almost similar. Okay, but the day, the more we actually progress towards 2011, and now we are already in 2014, we have seen the exponential growth of the unstructured and the semi-structured data. Okay, but the structured data are still growing in a very slow pace and all, but the exponential growth of my other two types of variety of data is something which is leading, which is actually inviting me to going for some other solution which will actually help me to save this data and to do lot of query or faster processing and those kind of stuffs. This is also another very important point that we need to keep in mind, that why I need something else. Okay, now having said all these issues or maybe all these challenges, right, how NoSQL technologies will give me that, or how NoSQL technologies will come as a rescue. Okay, as I said, I know that scaling up will have some challenges. So scaling up will have some limitations after some point of time. So I need to scale out. I need to have distributed architecture. The moment I need to have distributed architecture, obviously I am inviting some other challenges. Challenges in the sense, you just try to visualize, friends. You had 1 TB of data. Now you have distributed that 1 TB of data into 10 systems, right? Earlier you just need to maintain only one system, correct? But now the moment you have distributed into 10 different systems, you have to keep in mind, I have to maintain all these 10 different systems. That means my maintenance will go high. So NoSQL, or whatever the solution is, the solution should provide you easy to maintain the large number of nodes, or as well as easy to scale out. Okay, it's not only easy to scale out, it might so happen that at some point of time in the year, or a specified point of time in the year, you face a lot of user bases, right? You get a lot of user bases. That time your data is growing higher and higher and higher, and at some point of time you don't have that many usages of, and you can actually scale down your application also. So it's not only easy to scale out, but also easy to scale down. Some elasticity needs to be maintained by your new solution, this NoSQL solution. So that is something which is provided. Fast reads. Okay, now why we are saying fast read, fast read, fast read? Okay, one more thing, friends, just keep in mind this. In the year of this 2006, 2007, and that time frame, right, we also have started seeing some applications are gaining popularity, which are not only which are not only these banking applications or insurance applications or hospital management system, where the relationships can be there and all. We have started seeing few applications where people will write data only one time but read many times. This write once and read many times behavior we have started in many applications, most of the applications rather, different blogger applications, your the social media applications. Okay, the applications like Wikipedia, right? So most of the application we have started seeing that people will write maybe once, and edit also will be very less, correct? But read will be very high. When most of the applications are read heavy applications, that's the reason we initially we told that fast reads, correct? Now that's the reason I said fast satisfying write once read many times behavior. So your NoSQL solution needs to have that. Easy replication. What is replication? Again, the moment, as I said, distributed architecture, right? Distributed architecture means I am inviting other challenges. What are challenges? Let's say you have distributed your data into multiple systems. That means you have to maintain those multiple systems. The moment you have the moment you have multiple systems, your number of failover points are more, correct? Your number of failover points are more. So if one of the system goes down, right, you will lose that part of data, that 100 GB of data. You're trying to visualize, correct? Now we need to see, I need to have some mechanism so that even if one of my node goes down, some way I have to support, some way I have to have the availability. So I need to replicate that, so that even if one node goes down, I need to support the user, I can support the user. So you need to have a replication mechanism, a failover solution, a very good failover solution by these technologies. So any of the big data technologies you take, they try to give this easy replication stuffs. Higher performance and architecture providing much higher power node performance than available from the traditional SQL based systems. Obviously it has to give you power node higher performance, right? Again, schema free. When we say schema free, friends, what do we mean by schema of your data model? So whenever you started designing some application, right, you design your data model, you actually define your schema first in your traditional RDBMS, right? So you define your table, you have your row column definitions, you have your foreign key constraints and all those kind of stuff, right? And you start developing it. Let's say tomorrow there is a change. Okay, tomorrow there is a change comes. So what will you do? You go and change your data model. The moment you go and change your data model, you have to do the corresponding changes in your application layer. And also, if you are using a veracity layer, object relationship mapping like Hibernate or SQL IBET, so those kind of stuffs, right? So if you are using some ORM layer between your database and your application, you have to do the changes there as well, correct? You, as far as the deployment is concerned, you have to do the deployment for your DDL, then your application can be deployed and those kind of stuff. So all I'm saying is the whole process of time to go to market, the whole process of development window is basically is basically increased, right? So why, if my application or if my requirement is subject to change, and why don't I have some technology which supports some flexible or dynamic schema, or changing the schema is very easy. For that, probably I don't have much impact on my application. So your NoSQL technology, whatever thing that you are actually going for, right, it needs to have that behavior as well, to cope up with the agility of the world, to cope up with this change of the world, faster development time and all. Fast development, as I said, no need of the additional ORM layer. Now, friends, all I'm saying is advantage, advantage, advantage. Very good. But not everything is so smooth, obviously. The moment we are, again, I'm emphasizing on this particular phrase every time, friends. The moment we are going for distributed architecture, we are inviting challenges. We are going for distributed architecture to gain in performance, to gain in the response times, right? So in that case, we have to draw some line, we have to draw some we have to have some compromises. We'll have to, the compromises in some of the cases, especially in MongoDB that we have today, is there are no joins across multiple tables. Though we do not call tables here, we call collection. Those will be part of the greater discussion of your MongoDB class, but just for your information, there are no joins. The only reason is that was an architecture decision that we will not use join, because if you use join in a distributed environment, your response times has to go down. It will be reduced. It sorry, response time will be more, actually, not reduced. I mean, it will not be that faster. So it was an architectural decision that there will be no join across multiple tables or multiple collections in this particular case. Okay, and also, as far as the transaction, ACID property of transaction is concerned, most of the NoSQL technology, it does not provide ACID transaction. When I say ACID transaction, atomicity, consistency, interoperability and durability. Isolation and durability, correct? So though it supports some kind of base property, we'll come to it later, but it does not support a full ACID transaction. You might think if a database is not supporting transaction, how will how my rollback will happen, correct? So with this limitation, the way that the data model we need to design, right, that will actually support or that will actually cover up, or that will actually overcome these limitations. That's how it has been designed, that's how it has been suggested. The way we need to do the data model design, it's totally different than than in case of RDBMS. It's totally a paradigm shift. We'll try to see some kind of flavor of data model design in today's brief introduction section as well. Okay, now just one quick thing. When we have started facing this issue, right, when you have started facing some requirement of having something else, some other storage mechanism, some other persistence mechanism, right, and and we are thinking of, let's say, MongoDB or any other NoSQL database, what people have found is, yes, we can give better performance, we can give a lot of functionalities, and obviously we'll have to have some kind of compromisation as well. Where MongoDB stands in these respect, you can see in this particular graph. So memcached, key value stores, these are some of the technologies which will give you very fast performance, very good scalability, and those kind of stuffs. Memcached, key value stores, these are nothing but if you have a key, you will get the value. So and it's distributed as well, so it's pretty fast, and it's very fast actually. So what kind of functionality it has? You get some query, you simply ask from the key value stores or memcached, okay, I have got this key, do you have the value? Yes, you have the value, get me the value, so that you don't have to go to all the way to the database, right? These are the solutions. It's very fast. But what it does not provide, it does not provide you a lot of rich functionality like structure, unstructured, or different kinds of query mechanism, or different kinds of indexing mechanism. It doesn't provide these many features to you. It just gives you a raw, very excellent performance. That's it. So it's actually compromising with the functionality, with the scalability and performance, with gaining scalability and performance, right? Where in RDBMS it gives a lot of rich functionalities, but the moment we see that the depth of functions are very high, but the moment we have seen as far as scalability and performance is concerned, we have seen some issues in case of traditional RDBMS systems. Where MongoDB stands is something in between. MongoDB says that we will give you scalability, we will give you performance, okay, yes, and also we will give you a lot of functionalities, but not everything. To why not everything? To compromise, we will not compromise with the scalability and performance. So to gain with the scalability and performance, we'll actually compromise some of the functionalities like join, like transaction, and those kind of stuffs. Understood, right? So here how MongoDB stands, and where actually we stand today, and as far as this depth of functionality and scalability and performance is concerned. Okay, before I go ahead, I'll see some questions there. Let me quickly take some questions so that okay, I think there are a lot of questions. I'm not sure whether I can take everything or not, but let's see. Okay, some of the people okay, some face some internet issues, that's fine, but most of the thing are there. Okay, so Pramod is saying, will MongoDB play an important role in cloud computing environment? Yes, Pramod, that's an excellent question. Yes, obviously, because as far as hardware is concerned, the way we are moving, right? So most of the cases that we want to depend on hardware from the cloud, right? So MongoDB is very much good for cloud computing. So it can be deployed in cloud as well. Okay. Then Pramod is saying, how is the performance tuning in MongoDB? Yes, Pramod, so there are options of tuning performance, like tuning your this thing, query performance and different stuff. There are options in MongoDB. Okay. Raja is saying, hope you will explain more about MongoDB also. Yes, Raja. Next things, what we will do is we'll just see some of the features of MongoDB, and I'll try to see some use cases of MongoDB, try to capture some of the data model concept as well. Though we don't have much time, but I'll just try to see. Vishal is saying this is kind of talking more about the general big data concept. Yes, Vishal, that's right. We'll slowly we are getting into MongoDB. Shiva is saying, can we do data replication? Yes, obviously we can do data replication. Ankit is saying, hi, I'm getting confused between Hadoop and MongoDB process. Could you please clarify me? I mean, how MongoDB is different than Hadoop? Okay, I think that's a common question from most of them. So let me answer this question. So when we are having this big data solution, right? So there are two aspects of it. One, we can call it online big data, and one offline big data. When we are saying online big data, means the way, if you are having some solution which will actually give you provisions to create online some online transaction processing systems, or some near real-time systems, right? Those are online big data we can call. MongoDB is one of them. So using MongoDB you can develop near real-time systems. Okay, you don't have to do it everything in the background. So that's the beauty of MongoDB. But in case of Hadoop is mainly doing processing of the data, mainly in the offline. Okay, so using your map reduce frameworks and all, right? So that's the reason it's called offline big data. So there are two different concepts. So MongoDB, Neo4j, Cassandra, you can use it both in online as well as in offline, but Hadoop is mainly for your offline processes. And Hadoop is mainly a framework which gives different flavors like MapReduce, Pig, Hive, and those kind of stuffs, right? Ankit, I think that should be clear. Vishal is saying, which one is better, Cassandra and MongoDB, or both? So Vishal, that's a very critical question. I'll come to a slide. I have a slide to answer this question. Just hold on for a second. After this one, I'll just come to it. Can we update data? Yes, we can update data, Vishal. Abhishek was temporarily, I think he was not able to hear me. I'm not sure whether the problem is still there, but most of the people, I did not see that issue. Panit is saying, in regards to MongoDB, is there a Oracle trigger equivalent? I could not find anything similar. Panit, in MongoDB, we do not have a trigger kind of stuff. We do not have anything like that. But similar kind of thing you can develop actually. Okay, it's not trigger, but you can develop some scheduler, but that is not using MongoDB though. You can use some other technologies to do that. So as far as trigger is concerned, we do not have any trigger in MongoDB. Raja is saying, what about Memcached? Could you please explain? So Memcached is a technology, Raja, which will actually give us caching solution, which do not have a lot of features, but it's just a key value things. Okay. So you save something, you give the key, whether the value is there, you'll get it. That's it, nothing else. You don't have that much of query facility and those kind of stuffs. And it's obviously very easily scalable and elastic in behavior as well. Okay. Jaya is saying, shall we install MongoDB in your local system to practice? If so, could you explain? Jaya, this particular session is not for that. When you actually attend the actual classes, right? MongoDB, there will be a lot of practicals, installations, configurations, performance tuning, administration, everything. Okay. Aman is saying, how is security issue related to MongoDB? Yes, Aman, there are MongoDB provides a lot of provisions to secure your database using along with your including the SSL security, encryption security, PEM file security. Okay, those kind of stuffs are there in MongoDB. Raja is saying, can we make MongoDB as alternative for SQL Server 2012? Raja, I would say yes, and as well as no. It's actually depends on the situation where you actually want to use it. Okay, when I'm saying okay, friends, as a very basic question, when I'm saying not only SQL, means it might so happen that it might not be a one-to-one replacement of your current RDBMS. It might so happen that you need to have some kind of some kind of hybrid structure. Some functionality will be there in some functionality will be there in your RDBMS. Some functionality will be there in your MongoDB. So that's also might happen. It's not that in everything can be one-to-one replace. Vishal is saying, can we update data? Yes, Vishal, we can update data. Sai is saying, what is NoSQL? So as I said, Sai, NoSQL is not only SQL. So not only SQL is sufficing, it's able to suffice your need. Okay, do application servers, WebSphere and WebLogic can be connected via any drivers to MongoDB? Yes, Santosh, we have drivers, almost all popular languages we can connect to MongoDB using drivers like Java, C++, Python, Node.js, .NET. So we have most of them. Okay, Nitin is saying, is MongoDB also schema free? Yes, Nitin, MongoDB is schema free. Aditya is saying, what is the compatibility of these NoSQL with the front and middleware languages? So compatibility in the sense, MongoDB is getting supported by almost all the languages in today's world, Aditya. Santosh is saying, do application servers, WebSphere and WebLogic can be connected? As I said, Santosh, I think you have already got the answer. Okay. Sita Ramaya says, can we have better opportunities for MongoDB in future? Yes, Sita Ramaya, I'll share some slides about the job trends currently about MongoDB, so no issues. Kamal is saying, if you could share some practical examples to relate entire concept of MongoDB. Yes, I'll share that. Pramod is saying, Pramod, are you not able to hear me? Because I think a lot of people, they have sent some questions and they are getting my responses. Nasir is saying, is there any certification program for MongoDB which is industry standard? Yes, Nasir, MongoDB company itself, they provide a certification program. Okay, so I think now let's I have to go back to my slides because it's already 8:52. Okay, friends, I'll just start to go ahead so that I can cover some of the basic stuffs. Otherwise, we won't be able to complete it. Okay, now as far as distributed architecture is concerned, right, there is a cap theorem which says that any of the distributed architecture can specify any of the two aspects of these three properties of these three. No one can support all these three aspects at one time. What are the three basic requirements? Consistency, availability, and partition tolerance. Consistency, I think you know. This means the data in database remains consistent after the execution of an operation, right? Availability, obviously, system somehow has to be available everywhere. I mean, it has to guarantee the availability, correct? No downtime. And partition tolerance, when you are actually distributing the data, right, this means that the system continues to function even if communication among servers is unreliable. So for example, when you are distributing the data, right, say for example, one of your node is going down for some example, but you are able to tolerate the partitions. Okay, how better you are good, how good you are in your partition tolerance. Okay, now in any of the cases, not all the three can be solved by one technology. Any two can be solved. Okay, why? Because when you are actually having consistency and availability, you won't be able to support partition tolerance. When you are actually supporting consistency and partition tolerance, availability, somewhere you might have to compromise somewhere. Okay, so if you see this diagram, right, according to the cap theorem, our RDBMS stands here. Why I'm saying consistency and availability we can have, but the moment I am actually partitioning the data, I am having some problem. So that's the reason. As far as the distributed architecture is concerned, make sure this is a distributed architecture. MongoDB sits somewhere here. Consistency and partition tolerance, very good in partition tolerance, very good in consistency, but there are some issues with the availability because there are some single point of failure is there. In HBase as well, right, like that name node and data node concept, right? So there is some compromisation in terms of availability. Then availability and persistence, like CouchDB, Cassandra, this will give you availability and persistence very good, but they will be compromising little bit of in case of consistency. So any one NoSQL database can support two of these three at any point of time as far as distributed architecture is concerned. Okay, so this is what we were talking about this base system instead of acid system. Okay, so basically it will be available. Basically available indicates the system does guarantee availability in terms of cap theorem. Okay, I mean, as I said that as far as cap theorem, it will guarantee the availability somewhere. Basically it will be available. What is soft state? Soft state indicates that the state of the system may change over time even without input, because there are a lot of nodes, right? So replication will happen. So one of the node may lag behind the other node sometime, correct? But it will be its state will get changed over time. Okay, even if user is not sending any input, the other nodes which are actually lagging behind, it will actually get the replicated or updated data from the other node. Okay, and this is because of this eventual consistency, because eventually that will be consistent. Maybe it will take some time, but it will be consistent. Eventual consistency indicates that the system will become consistent over time, maybe it will take some time, 1 or 2 seconds here and there, right? But it will come consistent. Okay, just information for you that there are 150, near equal to 150 NoSQL databases in the market today, but obviously not everything is as popular as our MongoDB is concerned. Now, some of you have got questions like why MongoDB, why Cassandra, why Hadoop, and those kind of stuffs, right? Okay, this is the slide. Now, this slide is a very important one. Just try to listen it very carefully. When we are saying NoSQL databases, right, it comes with different flavor. When I'm saying different flavor, based on the requirement, the structures are different. Okay, we have something called key value stores. What is this key value stores? Is the simplest NoSQL database. I mean, your memcached, okay, it's a key, it's an example of your key value store. You just put a key and value, that's it, nothing else. So it's a simplest NoSQL databases. Every single item in the database is stored as an attribute together with its value, and that's it. Okay, now let's say if you have some structure in your application, a lot of hierarchies, like your friends, and his and her friends, something of that kind. Or maybe let's say Wikipedia, some content linked to that, some other content. Okay, some hierarchy in a company. Let's say you have your boss, and then your team member, something, or boss's boss. Okay, this hierarchy. So whenever you have some tree structure or hierarchical database, right, we have something called graph store. Some examples like Neo4j, GraphDB, these are some of the examples of these graph stores. Okay, and maybe it's used hugely in case of this social media things and all, like where a lot of friends connects and those kind of stuffs are there, like LinkedIn, Facebook, Twitter, those kind of stuffs are there, right? So we use this graph store in a huge way. Wide columnar stores. Now when I'm saying that I am actually removing joins, that means what I'm trying to say, friend, here is I'm actually trying to denormalize my table. There are, let's say, 2-3 tables are there. I put everything in one table so that my read is very fast. The moment I remove join, my read will be very fast. Cassandra is an example where my store is a wide columnar way actually. Okay, it's everything in a column family kind of stuff. Cassandra or HBase, okay, optimized for queries over large data sets, right? And our very own MongoDB is actually supporting a document base. What is a document? Document is nothing but a structure of an object in your application itself. The similar structure, you can save it in your database itself. I'll just come to it in the next slide, that how a document is it looks like. MongoDB has support of this document, which is a JSON format, which is a JavaScript object notation formatted documents. Okay, it saves in a JavaScript a JSON formatted way. We call it JavaScript object notation. It doesn't have a row value, or if it doesn't have a row column kind of stuffs. In a document you can have key value though, but you can have documents and nested documents and those kind of stuffs. I'll come to it with an example. And some other examples like key value stores. These are the databases like memcached, coherence, redis are come under this key value stores. So all these are NoSQL database. Okay, graph stores, as I said. Okay. Now, as you are asking that why, what is better, like Cassandra or MongoDB? Somebody asked that question. So the selection of the NoSQL database is a very critical thing, friends. So before selecting of the NoSQL technology, which NoSQL technology I will select, you need to know that, or you need to keep in mind how your data model will look like, or what is your user requirement. Does it require a graph structure, a tree, or hierarchical structure? Then probably you'll go for a graph DB kind of stuff. Or let's say you don't have many relations, you can put it in similar format, or you can put it in a columnar way in one table itself in a denormalized fashion. Probably you can go with Cassandra or HBase. But let's say you have a requirement of having a database which will actually give you similar structure of your application layer objects. Okay, you can directly save it there, you can read it very fast, you can see the object structure and those kind of stuffs. You can go with MongoDB. Not only that, there are other stuffs as well. If you remember cap theorem, what is the priority of your application? Is that something availability will should be should get much priority than your consistency? Then probably you can go with Cassandra, which will actually give you availability and partition tolerance. But let's say you can compromise with your availability, but you cannot compromise with your consistency, for some example, in your application. Then probably you can go with MongoDB, something of that kind. So these are the aspects that you need to keep in mind before selecting a NoSQL database. It's a very important thing. Obviously, in the actual classes, this will be discussed in great detail. We'll discuss it in great detail, like with different use cases, in which use case which NoSQL technology will fit. We'll see that. As I said, like pros and cons and consistency and different features of RDBMS and those kind of stuffs. So you'll have to look. So these are the comparison structure. If you just just take a second to read through that. One type SQL with minor version, but in case of NoSQL we have many type of NoSQL databases. So it totally depends on your application requirement, that how your application data gets saved. Depending on that, you will actually select your NoSQL database. Okay, development 1970 2000. Examples also has been given. Schema, fixed, dynamic, vertical, horizontal scaling, that also we have discussed. And most of the NoSQL databases are open source, so that's a important thing. So it's not that you have to have a license and those kind of stuff. You have to install it, and then only you can use it. Most of the NoSQL databases, that they are open source. Simply download and start using it. Okay, and follow ACID and follow base. So these are the comparison of this. Okay, now going to a traditional going to a use case, right? Just look into this diagram once. Let's say there is an application where I need to develop this application using my RDBMS or using my traditional database management system. Okay, I have put some caching layer there. I have the web application which will read from the caching layer, and I'll send the data to the UI, for example. Okay, and I have got this application designed, and it is supporting, let's say, 1000 transaction per seconds. Okay, something of that kind. So some data has been given here. Now think of a situation when my data is started growing. Okay, if it started growing and I am having some problem of scaling out my data with my RDBMS, let's say I can go and I'm struggling with the performance, so I can go with the NoSQL solution itself. So in that case, what will happen is, elastically I can scale my different NoSQL data nodes with the higher user expectation, and also I can get gain in performance as well. All I'm trying to say, friends, is in that case your application layer will be untouched. Okay, so I mean, with the change in your architecture, with the change in your scaling out architecture of your NoSQL database or MongoDB, for example, your application layer will be untouched with no downtime. You can do that. Just think of the situation in case of traditional RDBMS system. In case you have to do some database monitoring activity, right? You have to get a downtime. You have to bring down a lot of the nodes. You have to go for maintenance period and those kind of stuffs and all, right? But in case of NoSQL, with zero downtime, you can scale out or scale down your persistence management, persistence layer. Your web application is untouched. And also in this case, we do not need any ORM or in a middle layer itself. NoSQL itself or MongoDB itself, it provides a caching layer. You don't have to have a separate ORM layer. This is one of the examples that I wanted to give you. Now I'll go and try to cover an real life example where I will try to do a data model, okay, with MongoDB and in RDBMS. So let's say, just read through this slide. For example, friends, suppose a client needs database design for his blog website with the below features. Then what could be difference between RDBMS and MongoDB schema design approach? Okay, just read through the requirement. What are the requirements? So the website has the following requirements. Every post has the unique title, description, and URL. Every post can have one or more tags. Every post has name of its publisher and total number of likes. Every post have comments given by users along with their name, message, data time, and likes. On each post there can be 0 or more comments. Okay, so if I need to design this application using RDBMS, how do I do? Now this slide will tell you that how do I do it in a traditional way. So probably I'll have one post table where I have ID, title, description, URL, likes, and post by, something of that kind. And I have because one post can have multiple comments and one post can have multiple tags, correct? So I'll have a 1:2 in relationship between cardinality between this post and tag table, where I have this foreign key relation called post ID, okay, and I have this ID and tag in the tag table. And in case of comments as well, what I can have is I can have comment ID, post ID as a foreign key with this post table, then the username, message, the time, and how many number of likes it has got. So this can be a traditional way of designing my data model for this particular application. And I think I need 3 tables. Say for example, in this particular case, if I need to show all the posts or in the blog, right? So I'll have to actually join these 3 tables. I'll have to scan these 3 tables across and get the data, right? Now let's say if I need to design it in MongoDB, how do I do that? See this thing. As I said, MongoDB stores a document format or a document database, right? So everything in MongoDB is a document. What is a document? Document is nothing but your your application object structure, equivalent application object structure in terms of JSON form, in JSON formatted. So this is a JSON string. This full thing is a JSON string. If you do not know JSON, then don't worry. I mean, in the actual classes there will be a detailed section of explaining what is JSON and all. Okay, how we should work with JSON, different data types of JSON, and those kind of stuff. It's there. So don't worry about that. Just think that JSON is a JavaScript object format. Okay, JavaScript object notation. This is a JSON object. Now look into this thing, friend. This is one object. This is one document. In one object itself, I have all the information like post ID, title, description, post by, URL of the post, the tags, which I have a different table altogether. In this case, what I have done is, in case of tags, I have simply created one array and I have put the tags in a comma separated way. I simply remove that relationship stuffs. Also comments, also I have get another array, some nested documents I have created in case of comments. If you see some nested documents like user, message, date created, likes, and those kind of stuffs in one document itself. So to read the to read any one post, I do not have to go to in any other table or in any other collection. To be very specific for MongoDB, we do not have to go to in any other table. We do not have to do any join at all. It's only this table itself I can go, or its collection itself I can go and get the data. That's the difference. Now let's say tomorrow you have a new field coming up, okay, something like, forwarded by, or some date, or created by, or some other field. In this particular case, in which table that it comes, right, you have to add that into your database, you have to create that DDL, you have to run that DDL, you come to your application layer and do the corresponding change. But as MongoDB is having a dynamic schema, you do not have to do any DDL kind of steps. The moment you have something different, you can simply insert that into MongoDB. You do not have to write any other DDL kind of stuffs. You do not have any changes in your application layer. The only change is to support that new flag or new attribute, and that's it. You don't have to have anything else. So if you see, while in MongoDB, schema design will have only one collection and has the following structure. So while showing the data in RDBMS, we need to join 3 tables, and in MongoDB, data will be shown from the collection. So while selecting your application, you see that, or selecting your NoSQL technology, you see that whether your data can be put into our object format, and whether you can have the related data in one collection itself. You don't have to go through multiple collections, so that you can avoid joins, so that you can avoid transactions across different tables, right? If those things are yes, you go with MongoDB. But if these things are no, then there are some issues. I mean, probably MongoDB is not the solution for you. So those are the things. Where to use MongoDB? Yeah, you can obviously use that as a replacement of your RDBMS for your web applications, but keep in mind those limitations as well. Semi-structured content management. In many of the cases, friends, we have been using this. We have been using MongoDB for semi-structured content management systems. CMS platform, a lot of CMS platforms, they are using MongoDB. Real-time analytics and high-speed logging. Yes, so high-speed logging also is one of the use cases where MongoDB is getting used hugely in the industry. Real-time analytics as well. As I said, Hadoop is mostly offline analytics and doing processing in the background and all. But in MongoDB, there are some frameworks called aggregation and all, using which you can do real-time analytics in your application. You don't have to wait, or you don't have to do any offline things and all. Caching and high scalability, yes. Web 2.0, media, SaaS, gaming. So all these cases, you can use MongoDB. The link also we have given, so you can just see that. And these are the big names who are actually using MongoDB today. Okay, like MetLife, eBay, MTV, SourceForge, Craigslist, ADP, and they are using it very successfully. Okay, and these are some of the big names who are actually using MongoDB today. Okay, now industry and domains where MongoDB is used, like financial service, you can use real risk analytics. Analytics is a very important way where MongoDB can be used. Okay, portfolio management, order capture, time series data, reference data management, right? In the government sector as well, probably right? In other project of government India, they're using MongoDB. Okay, in practical. Surveillance data aggregation, crime data management system and analytics. Okay, citizen engagement platform. So these are the okay. In case of healthcare also, it's gaining a lot of advantages, like 360-degree patient view, population management for at-risk demographics. Okay, lab data management and analytics, mobile apps, doctors, nurse, electronic healthcare. Okay, there also you can use it. Media entertainment, user data management, content management, digital assets management. As I said, we are having a lot of unstructured and semi-structured data. So in these cases, content archiving, social and media, mobile and social apps. A lot of cases we are using MongoDB today. In retail we are using MongoDB in hugely, like in case of product catalogs, where the price change will happen very less, but read will happen very fast, something of that kind, right? In those cases, I mean, read will be more than write. in most of the cases. News services, digital coupon, real-time price optimization, even real-time price optimization also you can do. In telecommunication, like consumer cloud, product catalog, customer service improvement, machine-to-machine platform. So these are the use cases where MongoDB are getting used today. Okay, so some of the statistics for you friends, how popular is MongoDB in the industry? So this is a Google search. This is a Google search, provides a wide indicator of MongoDB adoption in industry. So if you see this green area is how the popularity of MongoDB is gaining day by day. And just for your information, last year MongoDB has been named as Database Management of the Year, and today it's the 5th popular database in the world, in the industry, where it can be used in both online as well as offline processes. That's the advantage, that's the key thing for MongoDB. So these are the trend, how it's gaining with popularity. And some of the stuff that we have tried to give you some job opportunity trend of MongoDB, starting from 2010 2011, that timeline, right? You can see the trend, how this is also, we have taken it from some of the authentic site. So right, and where not to use MongoDB, as I said, not everything is smooth, friends. So when you are saying you have some highly transactional applications, right, where you have a lot of transactions happening, like banking transactions, okay, insurance application and those kind of stuff, right? In those use cases, MongoDB is not preferred because it does not support ACID transaction across different collections. So you simply do not use MongoDB in those cases. Okay. Applications with traditional database systems request such as foreign key constraints and etc. So if you see that you cannot design an application where you can avoid your relationship stuffs in one of in one collection or something of that sort, right? As I showed you earlier, right? And you have to have some relationships and those kind of stuffs, then better not to use MongoDB in those cases. But yes, there are workaround as well. These data modeling concept and designing of data model concept we will be discussing in great detail in our actual classes. Obviously this class is not for that. We don't have that much of time also. Okay, so yeah, so now it is time for questions. Let's see how many questions we can take. Okay, so okay, Shruti Mehta saying, what is the difference between SAS and MongoDB? So software as a service, and it's a two different thing actually, Shruti, although she's offline as well. Aditya is saying Java, .NET, PHP, etc. Yes, Aditya, we have the driver for Java, .NET, PHP, Python, C++, Node.js, almost all the Perl, almost all the popular languages we have drivers. Vishal is saying which NoSQL DB is popular in the market. As I said, Vishal, Cassandra, MongoDB, Neo4j, all of them are popular age-based, but as far as the coverage is concerned, what I have seen is MongoDB is gaining much more popularity